Hi everyone, in this video we are going to see how we can create a custom system tray icon for our Electron application. So here I already created a new folder for this project called custom tray icon. The next thing I'm going to do is initialize a new npm project, and when that's done I'm going to install one of the dependencies we are going to use, that's Electron, and put together a really simple Electron application for the start. So create a source folder as usual, and inside of it create an index.js file. Also create a resources folder next to the source folder where you are going to put the index.html file. You can add here something simple, something like an HTML with a body that says custom system tray icon. The next step is to launch this very simple index file in a browser window. So let's import app browser window from Electron. Create the usual create window function, and inside of this function create a new instance of this browser window. So do that by declaring a new constant window equals new browser window, and give it some initial parameters like the starting width and the height. Next, we will have to get the path to our index.html file. So do that by creating another constant called index.html path equals path.resolve, and then dir name, and the second parameter is .resources / index.html. Now we have to import the path utility library that's part of Node.js. So just put a require at the beginning of the file, and as the final step do window.load file, and then give it the index.html path you created. Finally, tell Electron that when it's ready, call the create window function. As the last step, go to the package.json file and add here a start script. The start script is going to be Electron followed by a space and a dot. Also update the path to your index.js file to source/index.js. If we did everything all right, then npm start should start the Electron application. So we have here the contents of our index.html file and a working Electron application. So close this window now. And the next step will be creating a system tray menu. So we talked about the specifics of the system tray in the last video. I'm going to leave a link to that down in the description. But essentially what we are going to need is a new constant tray, and we'll create a new instance of tray. Now you have to import tray from Electron, and you also have to pass the tray a path to your tray icon. Now we don't have this yet, so we'll leave this empty for now. And as the next step, create a new function called get progress bar path. That isn't going to receive any parameters. It's just going to return a path to our progress bar image. So type path.resolve. First parameter is always the tier name, and the second parameter is going to be /resources/progressbar.png. We are going to use a library called pureimage to create this PNG image programmatically. We are going to run a specific command that's going to return us the CPU usage at any given moment. And we are going to feed that data to this library to create a progress bar. So as the next step, install the library. It's called pureimage. So type npm I pureimage and add the import const p image equals require pureimage. There is one more thing needed for pureimage to work. That's a font file, because we are going to have some text in the system tray. So I already prepared a file here for the font type we are going to use. That's the Roboto Mono font type. I downloaded this from Google Fonts, but you can get them basically anywhere. And as the next step, create the function that's going to dynamically create the progress bar. So this is going to be an async function called create progress bar image. It's going to receive one parameter, that's the CPU usage. Inside the function, create an image using pureimage. So create a new constant, image equals p image, and then use the static method of this module make to create an image that's 100 pixels wide and 20 pixels tall. The next step is to create another constant that's going to be the context equals image get context, and then as a parameter specify 2D. So what you see here really looks like the HTML canvas to the drawing API, and that's what pureimage is essentially. It's the JavaScript implementation of that same API, but you can use it in Electron or in Node.js. I'm going to leave a link in the description below to how pureimage or the HTML to the canvas API works. For now, I'm just going to explain the comments that I'm using in this example. So to create a rectangle that has a white background and its height is 20 pixels and its width is 100 pixels, you're going to start by saying context, fill style. So first, you're going to specify the background color of the thing you're about to draw. And as the next step, same context, you use the fill rect function. This function takes 4 parameters. As you can see here, the documentation already explains. So basically the first 2 parameters are the starting coordinates, and the second 2 parameters are the ending coordinates of this rectangle. So that's going to be 100 by 20. So this is nothing else than a simple white rectangle that's 20 by 100. We can already create an image from this. So let's do that and let's see how that looks in the system tray. So to create an image from this 2D context, you are going to use p_image and then the encode png to stream function. The first parameter is the image, and the second parameter is going to be a write stream, where we essentially tell p_image where to write the result of this encoding. So start by using the fs, the file system module. So maybe import that first. And then use the create write stream function of it. And as the only required parameter here, pass the path to our progress bar. So this is the location where P-image is going to write the result of this encoding. We can already test the result of create progress bar image and see how our tray image is going to look like if we call create progress bar image right before we create the tray. So type await create progress bar image. Remember, this is an async function. We are not going to pass in any arguments here because we are not using CPU usage anyway just yet. But because we added here the await keyword, we will have to make this create window function async as well. So add async here. And for the tray, pass in the path to our progress bar that's going to be returned by this function. So go to the terminal and type npm start. As you can see, the white rectangle in the system tray appeared. So close the application and let's continue extending the create progress bar image function. Add another rectangle inside of it. That's going to be the variable part of the progress bar. Based on the CPU usage number, it's going to have a variable width. So create another rectangle using context. Now set the fill style to, for example, green. And now when making the rectangle, use the same starting coordinates, but for the width of the rectangle, we are going to use CPU usage. And for the height, it's going to stay 20 pixels. Now, let's try if this works. So here, where we call create progress bar image, just pass, for example, 25. And let's see what npm start gives us. So we see now two rectangles, the white that we had in the start, and now the green rectangle that's going to indicate the CPU usage. Close the Electron application and let's figure out how we can get the actual CPU usage from our operating system. So I just went to Stack Overflow and found this command that when you execute, it's going to return the CPU usage in percentage. It's above 100% for me because I have multiple cores, 6, I believe. So besides using this command, we are going to tweak the create progress bar image function a bit, because this is going to be always, I believe almost always, above 100%. So because I have 6 cores, and I don't know if this is a correct calculation, but it's definitely not going to let the progress bar, the green part of the progress bar, run out of the white area. So let's take CPU usage, rename it to CPU usage row, and then calculate CPU usage by taking CPU usage row and by dividing it with 6. Because I have 6 cores. Again, I don't know if this makes sense, but it's not going to let the green area to run out from the white. I hope so, at least. So next, we are going to find a way to run this command from our Electron application. To do that, we are going to use a package called child process, and more specifically, the exec module from it. So add this child process import. You don't have to install this, this is built in. And then create a function called check CPU usage. So it's a function. The way how you run this, or in fact any command, is you type exec and then paste here your command. The API of this function is a bit strange. It's not an async function, but it accepts a callback that has 3 parameters. The first is error, the second is standard out, This variable is going to contain this number, so the CPU usage, and the third parameter is standard error. So for the start, let's do some basic error handling. So if we have an error, just console log the error and return. If we have something in standard error, do the same thing. Log the standard error and return. Otherwise, we probably have our result. So log the result. It's in standard out. And this should do it. So check CPU usage and run it before we initialize the tray. You can see the CPU usage in percentages in the console, which is what we're doing on this line. So this works. You can quit the application. What we want essentially is to pass this number to the create progress bar image function. The problem is that this number is captured inside this callback function. So in this form, there isn't really a way to get to this number outside of this function. Usually how you solve problems like this is you wrap the execution with a new promise. So return a new promise here. Give its callback function a resolve and a reject. And then wrap the whole function with the promise. And you're going to resolve the value of the standard out. And in case of errors, instead of just console logging the error, you're going to reject with these errors. Now, check CPU usage is an async function. So you can await this function and capture the resolved value of the promise. So create a constant CPU usage equals await check CPU usage. And let's put a console log on the next line to see if this works. Start the application. And we have here our console output with the CPU usage string and the value. So this is cool. The next thing is passing this CPU usage to the create progress bar image function. So our progress bar finally becomes dynamic. So just passing this value here, start the app again, and let's see what happens. So the progress bar appeared, and now the green area is based on the CPU usage at the moment when the application starts. So I'm going to start it a few times. Hopefully it's going to be a bit different every time. But you can see my point. To make the progress bar actually update, create an interval. And we will call this every 300 milliseconds. And inside of the interval function, grab the CPU usage number. So create a new constant called result equals check CPU usage. Take this result and pass it to the create progress bar image function, just like we did with CPU usage. And after that, we reset the image of our tray. So do that by calling tray.setImage and then passing the image path to our progress bar. Now to have an access to tray here, I will probably move this tray above set interval. So something like this. Now let's see how this works. Okay, so it doesn't, because we forgot to add async to the set intervals callback function. So let's fix that. We also forgot an await before check CPU usage. So we are actually awaiting the result of this function and getting that in result. So let's start the application, and we should see our system tray icon or the system tray image moving based on the CPU usage. So next, we are going to add some text to this progress bar. To do that, let's modify the create progress bar image by adding a new context instruction. So use context.fillStyle. Again, we are using a third color so it doesn't mix with the white background or the green. So this is going to be blue. And after changing the color, we should set the font style and the font size. So type context font equals, and then the first parameter here is the size of the font, and the second parameter is the font family. That's Roboto. If you remember, that's the Roboto font family we already pasted here in the resources folder. So for this to work, we need one more thing. We have to tell P-image that we have this font family, and we have to load it before we can use it. So create here a new constant called font, and then do P-image register font. Then grab the path to the font like this. Okay, and once we have this, we have to name the imported font. We are going to name it Roboto, so it has the same name like the font family. Next, call font load sync. And with this, you should have the Roboto font family available here, and you could use context, fill text, to actually create some text on your 2D canvas. Add CPU, then the CPU usage number to the system tray image. The first parameter of fill text is the text you are going to show, and the second and the third parameters are the XY coordinates where the upper left corner of the text is. So that's going to be 5 and 17 for us. Start the application, and we should see some text inside the progress bar. So this is how you create a dynamic progress bar image for your Electron applications. Thanks for watching, and see you in the next one. Bye.